Now the next topic is electric dipole. What is electric dipole? Electric dipole is a system of two particles, two charged particles or two charges. Which two charges? These two charges are equal in magnitude but opposite in direction and placed apart from each other at a particular or a fixed distance. This is called electric dipole. Electric dipole is denoted by P and the magnitude of charge, as we know, is Q. Distance between the charges is denoted by 2a. Why 2a? Because these two charges placed from center, one in left side and another in right side. That's why the total distance from center of one charge is a, and hence the total distance between two charges means the dipole is 2a. A line joining to the dipole means a positive charge to negative charge is called dipole axis. To describe the strength of electric dipole, we will use a physical quantity, that is electric dipole moment. And the dipole moment is a vector quantity and it's directed from negative charge to positive charge. Standard unit of electric dipole moment is coulomb into meter according to the formula, and the CGS or the small unit is dBi. 1 dBi is 3.3 into 10 to the power minus 30 coulomb. Now electric dipole can also exert electric field and electric potential. Next we will discuss electric field and potential due to the dipole on its axis and the bisector of dipole also. Let's find the electric field at the axial line of electric dipole. We can find the electric field either plus Q charge side or minus Q charge side. Intensity of electric field on the axial line of electric dipole is equal to K 2P by R cube. And the derivation of this formula is quite easy. First, we will start from the formula or a simple formula of electric field, that is equal to KQ by R square. Now, the point P is situated towards either minus Q side or plus Q side. You can take any of the example. In this case, our charge Q is placed towards the plus Q side and the distance between these two charges means the dipole is 2a. Distance of charge Q on the axial line from the center of dipole is small r. In this derivation, we will calculate individually electric field due to plus Q charge and minus Q charge, then we will add them. First we will calculate from the plus Q charge and equal to KQ by R square, where R is the distance of point from plus Q charge. Then the distance will be R minus A. For minus Q charge it will be R plus A, and in the mathematical solution 1 upon R plus A whole square minus 1 upon R minus A whole square. The quantity remain and the final formula we got equal to K 2P by R cube. And the same we can find the electric field on the equatorial line, and that electric field will be equal to Kp upon R cube. Now our next topic is electric dipole in uniform field or a uniform electric field. What happens when a dipole is placed in a uniform electric field? Dipole will experience a torque. Torque means two couple of force or two force directed in opposite direction at some distance. Plus Q charge will experience a force exactly in the opposite direction of minus Q charge, and as we know that these two charges separated by a distance 2a, that's why the couple of force will rotate the dipole along its central axis or the center point when it is placed in external electric field. We can also find direction of electric field due to the dipole or electric potential energy also. Now first we will calculate the electric torque on the dipole in the presence of external electric field, and that torque will be tau equal to Pe sin theta. How it is possible tau equal to Pe sin theta? Because the dipole is placed in uniform electric field at an angle theta. Then plus Q charge of dipole will move towards the external side or towards the side of electric field, and minus Q charge will shift in the opposite direction of external electric field. So the net force on the electric dipole is 0 in electric field, but the torque is the product of or the cross product of dipole moment and electric field, means tau vector equal to P vector cross E vector. And when the vector sign removes or cross product removes, we will got tau equal to Pe sin theta, where theta is the angle between electric dipole and electric field. We can also find the work done of electric dipole in the electric field, and that will be W equal to F dot dr, where F is the force and dr is the displacement. In case of rotational motion, as we have already discussed in class 11, chapter number 7, in rotational motion, linear displacement can be replaced by angular displacement and the force can be replaced by torque. That's why in this case, electric work done for the electric dipole, W will be tau into d theta, where tau is torque and d theta is angular displacement, which will describe the rotation of dipole. Integration of d theta will be theta, and when we put the limit theta 1 to theta 2, then it will become W equal to Pe cos theta 1 minus cos theta 2.